Projectile motion. This is one of those topics that I want to discuss because you will see that in JAM lectures, JAM papers, you get questions from this particular topic. And this will fall under the topic of kinematics. And I am very much sure that most of you have studied the projectile motion topic in your 12th or 11th, right? You understand what projectile motion is. But थोड़ा सा मैं theoretical discussion कर देता हूँ. Let us look at the various, physical quantities involved in projectile motion. Let us look at the various relationships for projectile motion. And then we'll try to solve a few problems. Keep in mind कि JAM में projectile motion के questions बहुत आते हैं. So this is one of those topics that requires a certain kind of sort of expertise. Okay. And the questions that you see in projectile motion are not necessarily easy. क्योंकि आपने हो सकता है IIT वगैरह जब दिया होगा तो projectile motion के questions आपने करे होंगे. But the questions that you'll see in JAM are not necessarily easy. अगर मैं आपको दे दूं 2-4 questions करने के लिए आप immediately solve नहीं कर पाओगे. So it's better that we spend some time and try to get comfortable with this particular topic, exclusively this particular topic. Okay, so let us start. Projectile motion is one of the most common sort of motions that we see in our day-to-day life. You know, we live in a macroscopic world and we are familiar with projectile motion like any other. Because every time you throw a ball, every time you play cricket, every time you play football, every time you play like badminton, or every time you play anything that has to do with the ball where you have to throw a ball, then you see projectile motion. Why? Because it is possible that you may throw a ball in the upward direction or at a particular angle, but the ball makes a very specific trajectory. The ball makes a very specific trajectory, and that trajectory is a trajectory of a parabola. आप लोगों ने शायद देखा है इस तरह का trajectory. You end up getting a parabola. Okay, ये circle हो गया, but आप इसको parabola imagine करो. ठीक है. I don't really have anything to draw a parabola right now. So think of it as a parabola. So this is the kind of trajectory that you usually see. All right. So let us look at the various quantities involved. Let's say this is the origin of the coordinate system. And let us say that the initial ball is thrown at a particular angle theta with a velocity or a speed of u. Okay. And this projectile covers a horizontal distance, which we call as range, and it climbs up to a particular vertical height that we simply call as capital H height. Okay. So if you look at the projectile motion, some of the things are already predefined. So if I say initial velocity, what is the initial velocity? U. Okay. Now, when I say initial velocity, first of all, the projectile motion is confined to a 2D plane. Okay. Confined to 2D plane. Matlab the simplest projectile motion. I'm not talking about the banana kick of Ronaldinho or Messi or somebody. Okay. That ball goes like this and then swings into a goal post. I'm not talking about that. I'm talking about the most simplest projectile motion that does not involve any kind of a rotational spin, that does not involve any kind of a drag force or any other forces. I'm talking about a very simple projectile motion which only has the point mass object that is moving through space and the gravitational force acting on the point mass object. In that kind of a scenario, you have the initial speed u that has components ux and uy. So ux uy अगर आपके पास है, so that means the speed along the x-axis, this is nothing but ux. The speed along the y-axis, this is uy. So it is clear from here what is ux. Ux is equal to u cos theta. Okay, and uy is equal to u sin theta. Okay. Now the question is, this is the initial velocity. What is the velocity at a later time t? Velocity at time t. Let's suppose I try to look at the velocity at a later time t somewhere here. Okay, at this particular point. So if I want to find out the velocity at a later time t, then the velocity at a later time will be something like this, right? Now it is clear that the velocity vector has changed. Whenever forces are involved, the velocity vector magnitude as well as the direction changes. And this v also has components along the x-axis and the y-axis. So this is vx. This is vx, and this is vy. Okay, so even vx and vy are the components of the velocity at a later time t. Now we can try to find out the various relationships that exist here. Okay, first of all, what is the force that is acting on the system? There is only one force as of right now. We are not interested in any kind of a rotational spin. We are not interested in any kind of a drag. It's a very ideal system of a point mass particle experiencing a projectile motion in a 2D plane. So in that kind of a system, we have a force along. First of all, मैं x-axis को देखता हूँ. So if you look at the x-axis, what is the force along the x-axis? What is fx? What is fx?
0, sir.
fx is
0.
equal to max is equal to 0. तो इसका मतलब क्या है? ax is equal to 0, which means
No change in velocity along x direction.
yes, x component of velocity is a constant. The x component of velocity is a constant का मतलब क्या है? It simply means that ux is equal to vx. That's it. Okay, ux. So ux, which is the initial x component of speed at time t is equal to 0, and vx, which is the later x component of velocity at a later point in time, is basically a constant, जिसको हम बोलेंगे u cos theta. तो ये जो आपका है ux is equal to u cos theta, this is a constant in time. First thing. Okay, but what about uy? To figure out something about uy, we need to talk about the forces along the y-axis. Along y-axis, what is Fy? What is the force along the y-axis? बताइए.
Gravity, sir. Minus
Gravity.
g.
Minus mg.
Minus mg. Minus क्यों लगाया मैंने यहाँ पे?
We have taken positive direction along upward.
Upward direction. Very
Downward
good.
direction.
Yes, gravity is in the downward direction. Positive y is along upward direction. Therefore, I take minus. So ma_y. So this is equal to ma_y, which simply means that ay is equal to minus g. So acceleration is equal to minus g. So basically, retardation is happening as a ball is moving upward. So y component of speed is not a constant. So therefore, vy is equal to uy plus ayt, or vy is equal to uy is u sin theta minus gt. So this is one equation. पहला इक्वेशन ये है. हाँ जी,
यहाँ पे सर एक बार रिपीट करना है, f(x) 0 कैसे हुआ?
बताइए x एक्सिस में फोर्स क्या लग रहा है?
सर जब हमने उस बॉल या फिर किसी भी ऑब्जेक्ट को फेंका तो स्टार्टिंग में जो फोर्स लगा होगा इसीलिए तो वो आगे जा रही है बॉल।
Okay. See, the thing is that when we study projectile motion, we are essentially studying the overall trajectory of the projectile motion the moment it is thrown. मतलब we are not studying the dynamics of ball पहले रेस्ट पे था और मैंने उसको फेंका, फेंकने की जगह मैं यहाँ एक तोप क्रिएट कर देता हूँ। एक तोप है, तोप के बीच में कुछ हुआ, एक गन है, लेट्स सपोज गन बोल देता हूँ मैं, एक गन है मेरा यहाँ पे, ठीक है। अब गन में कुछ हुआ, तो एक बुलेट चला गया, ठीक है। वी आर टॉकिंग अबाउट द मोमेंट द बुलेट कम्स इनटू मोशन। We are not interested in the dynamics of how the bullet came into motion from rest. Please try to understand. So we are not talking about गिरने के बाद क्या होता है, and we are not talking about गिरने से पहले का जो भी forces involved था. We are only talking about the moment the ball comes into motion. So the moment the ball comes into motion, of course, यहाँ पे एक छोटा सा explosion होता है. There is conservation of angular momentum, and because of conservation of angular momentum, the gun experiences a recoil, and the ball experiences certain kind of velocity in the forward direction. This is where our story begins. हमारी कहानी यहाँ शुरू होती है. So the moment the ball has an initial velocity, that is where we start our analysis.
ओके सर।
Are you understanding? So now,
यस सर।
हाँ, now here we start our analysis. अब मुझे बताओ x एक्सिस में क्या फोर्स है? कोई फोर्स नहीं है,
यस सर।
ठीक है, और y एक्सिस में फोर्स है। तो नाउ दैट इज गोइंग टू डिसाइड कि ये जो बॉल इनिशियली एक स्ट्रेट लाइन में जा रही थी वो इस तरफ क्यों कर्व हुई। समझ रहे हो ना? That is going to decide the overall trajectory because of the resultant forces present throughout the motion of the ball. Okay, throughout the motion of the ball. So yeah, now these are the equations associated with the instantaneous speed of the ball at any moment in time. Now that we have obtained the instantaneous speed of the ball, we can also obtain the distance traveled. So for example, if I am interested in figuring out how much distance has been traveled, और आप नोटिस कीजिए कि I am only focusing on the kinematics here. Okay, so along the x-axis, acceleration is 0, speed is a constant. So distance traveled will be given by equation of kinematics, x is equal to uxt plus half axt square. That means x is equal to u cos theta times t, or you can write t is equal to x upon u cos theta. So these are the two equations that connects the time with respect to the horizontal distance. So let's suppose this is point number 3. Okay, we call it, so this is the horizontal distance. Similarly, we can also calculate the vertical distance. So vertical distance के लिए we can have along y-axis, and y-axis, y is equal to uyt plus half ayt square, or y is equal to ui is u sin theta times t minus half g t square, basically यही है आपका. Okay, y is equal to ut sin theta minus half g t square. This is the equation corresponding to the vertical distance that is traveled with respect to time. Now using equation number 3 and equation number 4, we can also obtain an equation for the actual trajectory of this particle. ठीक है, जो actual trajectory है वो भी हम figure out कर सकते हैं, or an equation for the path of motion. So what is the actual trajectory? So what I'm going to do is substitute, use point number 3 in point number 4. So y is equal to u, t is equal to x upon u cos theta sin theta minus half g, t is equal to x upon u cos theta square. So this becomes y is equal to x tan theta minus g x square upon 2 u square cos square theta. This is the trajectory of the system. This is the trajectory of the system. All right, equation of trajectory or path of motion. All right, so we have obtained the expressions for the speed as well as the distance traveled along the x and the y axis. We've also obtained the equation of path of the motion. There are two important quantities that are relevant from problem solving perspective, which is related to how far the projectile can go along the horizontal plane and how far the projectile can climb up in the vertical direction, which are referred to as range and height respectively. वो भी हम calculate कर लेते हैं. And also one more quantity, the total amount of time period it takes for the projectile to go from point number O to point number, let's suppose P, which is known as a time of flight. So if I calculate the time of flight first, so time of flight हम equation of trajectory से निकाल सकते हैं. So at this point, y is equal to 0. At this point also, y is equal to 0. So if I put y is equal to 0 in the path of motion, I will obtain two solutions, one corresponding to the origin and the other corresponding to the final destination. तो मैं वही करूंगा यहाँ पे. Y is equal to 0 at time t is equal to capital T, which is the total amount of time period it takes for the entire projectile motion. So if I use equation number 5, this gives us 0 is equal to equation number 5 की जगह पे 4 use करते हैं. Equation number 4. So this gives y is equal to 0 is equal to u capital T sin theta minus half g capital T square. So this becomes u capital T sin theta is equal to half g capital T square. So one solution is t is equal to 0. वो solution हो गया cancel. I remove it. The remaining solution is for the complete time of the flight, which is capital T is equal to 2u sin theta upon g. This is the total amount of time period it requires for a projectile to go along a horizontal path. Okay, very important expression. So this is the time of flight is total time required for complete projectile motion in horizontal direction. In horizontal direction. Similarly, I can also calculate other quantities like the range in the horizontal direction. So if you look at the range is essentially x is equal to r. So, and the range is completed over full time of flight. So x is basically equal to r and t is equal to time of flight. So if I use equation number 3, x is equal to u cos theta t, equation number 3, x is equal to u cos theta t, and I substitute everything. This becomes r is equal to u capital T cos theta, which is nothing but u capital T is 2u sin theta upon g, and t cos theta, तो t हो गया, cos theta आ गया. So what is 2 sin theta cos theta?
Sin
U
2
square, yes, sin 2 theta upon g. This gives you the total horizontal distance traveled. Total horizontal distance traveled by projectile. Traveled by projectile. Now, based on this, if I ask you a simple question, at what angle, what value of theta r is maximum? इसका आंसर क्या होगा? आपको पता ही होगा क्या है?
45 degree.
5 degree.
Yes. So sin theta or sin 2 theta here, the maximum value of sin 2 theta is always equal to 1. So that means 2 theta is equal to 90 degrees or theta is equal to 45 degrees. That's why if you want to send a projectile to the furthest possible distance with a given amount of speed, then you should throw it at an angle of 45 degrees. And here we have again height. So height is y is equal to capital H. If you look at the motion of a projectile, the motion of a projectile is symmetric with respect to line dividing it from its center. So let's suppose this is r upon 2, and this is where the projectile reaches half its distance. So the entire trajectory is divided into half. So this is also corresponding, the vertical height is also corresponding to the total amount of height that we are concerned with. So यहाँ पे we can say y is equal to capital H and t is equal to capital T upon 2. So if I use equation number 4, I can say that y is equal to ut sin theta minus half gt square. Y is equal to ut sin theta minus half gt square. So then this is capital H is equal to u capital T upon 2 sin theta minus half g capital T upon 2 square. So therefore this becomes u, t is equal to 2u sin theta upon g, 2u sin theta upon g sin theta minus half g upon 4, 2u sin theta upon g square. So this is equals to 2 cancel, यहाँ पे 2 square और 4 cancel. So this becomes u square sin square theta upon g minus u square
Half of u square.
half of u square sin square theta upon 2g. So this is equal to u square sin square theta upon 2g. So this is the vertical height achieved by a projectile. Again, very important. These expressions are, so जो भी मैं यहाँ पे yellow में highlight कर रहा हूँ in this PDF as well as in the other lectures, please write them down in your formula sheets so that you can do a quick revision later on. So this is the vertical height climbed by the projectile. Vertical height climbed by the projectile. Okay, so these are more or less some of the various physical quantities we are interested in when we study projectile motion. If you are familiar with the general sort of a dynamics of particles in motion, तो ये सब आप obtain भी कर सकते हो. Just rough में you can do some calculations and you can obtain various expressions with just some amount of time. अगर force आपको पता है x axis में, you can find the speed, you can find the distance covered. अगर y axis में force आपको पता है, you can find the speed, you can find the distance traveled. You can also find out the total time taken. You can also find out the vertical distance traveled. You can also find out the horizontal distance traveled. सारा चीज आप usually figure out कर सकते हो. But बहुत बार क्या होता है, एग्जाम के टाइम पे हमारे पास इतना टाइम होता नहीं है that we can actually solve the equations of motion and then use those expressions to actually get the answer जो सवाल में पूछा गया, वो हमारे पास इतना टाइम नहीं होता. So therefore it's always beneficial if you can memorize these expressions, height, time of flight, range, or specifically initial and final velocities along x and y axis. ये सब अगर आप याद रख सकते हो, then all the better. Now this is more or less the sort of various physical quantities associated with projectile motion. Now when it comes to questions, the questions are very varied. मतलब if you look at the JAM papers, आपके पास simple questions भी आते हैं, आपके पास बहुत मुश्किल questions भी आते हैं. Questions can have all kinds of difficulty level. So let us look at a very few questions and let's try to solve them and see how we can apply these expressions while solving those questions. So आपके सामने मैं एक question रखता हूँ.
Sir, in VSC we have done projectile including drag force. Don't we have that in our JAM syllabus?
You have. We will discuss that topic when we discuss variable forces. So there is a topic called variable forces, and I will be discussing. I'll be extensively discussing variable forces, variable mass, variable acceleration. तो उस टॉपिक के अंदर आई विल कम बैक टू दीज काइंड्स ऑफ क्वेश्चंस अगेन. ठीक है, अभी मैं
Yes, sir.
वेरिएबल फोर्सेस और वेरिएबल मासेस का कॉन्सेप्ट इंक्लूड नहीं कर रहा हूं, क्योंकि उसमें क्या होता है, द मोमेंट यू इंक्लूड एनी काइंड ऑफ variable force as a result of either variable mass or as a result of drag forces, then what you have to do is you have to solve the equation of motion, which is essentially the second order differential equation. तो वो प्रॉब्लम थोड़ा सा अलग हो जाता है. And what I try to do is I try to sort of create a classification of problems, right? And right now I am only focused on ideal systems. Just give me a second. ताकि मैं नॉन आइडियल सिस्टम्स को मैं बाद में टैकल करूंगा. क्योंकि आइडियल सिस्टम में भी क्या होगा कि you will not be able to solve, right? There are so many questions that you will struggle with. तो पहले ये कर लेते हैं, फिर हम differential equation solve करेंगे. Okay. So this is a question for you. I don't know. Can you see the question? No. Yep. This is the question for you. All right. A particle of mass 2 kgs is projected with a speed of 10 root 2 meter per second at 45 degrees to the horizontal. After what time the velocity vector makes 30 degrees with the horizontal? Sounds like a simple question. It is a simple question, but थोड़ा सा समझने की जरूरत है, because this question is jam level question. Okay, एक प्रोजेक्टाइल है, इनिशियल स्पीड आपको दिया हुआ है, थीटा दिया हुआ है. दे आर आस्किंग यू आफ्टर व्हाट टाइम द वेलोसिटी वेक्टर मेक्स 30 डिग्रीज विद द हॉरिजॉन्टल. करना चाहोगे एक बार खुद से?
Yes, sir.
All right, take 3 minutes and try to solve it yourself. नहीं होता है, डोंट वरी अबाउट इट. आई होप दैट आप लोगों ने सारा नोट डाउन कर लिया, मैंने जितने भी इक्वेशंस डिराइव करे हैं, एंड यूजिंग दैट see if this is a question that you can solve. If you throw a projectile at 45 degrees, after what time the velocity vector makes 30 degrees with the horizontal? All right, I have a lot of answers. Swarnava, your answer is not correct. Kashan, your answer is correct. Pamdev, Rakesh, correct answer. Vivek, it's not correct. Check again. All right, I'm starting. ठीक है? So it's a very fairly simple question, but I am very much sure कि आप लोग थोड़ा सा इसको confuse हो गए करना क्या है, right? और मतलब कैसे करना है basically, how to go about it. So let us just try to understand the problem, and once we understand the problem, the solution will become obvious to us. Yashwant, your answer is correct. Good. So we have a projectile motion. All right. The projectile is thrown upwards with a speed of 10 root 2 meter per second. Okay. At an angle of 45 degrees. The mass is 2 kgs. All right. Now, at time t is equal to 0, at the origin, right, what is the initial speed? Ux is equal to u cos 45 degree. So this is equal to 10 root 2 times 1 upon root 2. So is 10 meter per second along the x-axis. And uy is equal to u sine 45 degree. So this is equal to 10 root 2 1 upon root 2 is equal to 10 meter per second. Initially, this is the x and y component of speed, right? At a later time t, हमें नहीं पता कि v क्या है, but vx क्या है पता है? What is vx at a later time t? vx
10
क्या है?
meter per second. 10 meter per second constant.
vx is
V
equal to
root 3 by 2.
vx is equal to ux is equal to 10 meter per second. vy क्या है हमें नहीं पता. So first of all, we have to be very careful कि पूछ क्या रहे हैं और हमें obtain क्या करना है, right? पूछ रहे हैं time. This is what is being asked. After how much time the velocity vector makes 30 degrees with the horizontal? मतलब basically they are asking that this should be 30 degrees, right? But यहाँ पे आप अगर एक चीज notice करेंगे, there are two distinct points at which the velocity vector makes 30 degrees with the horizontal. This is the first point, but there is another point. If we look here, अगर हम इसको notice करें, so this is v, this is vx, this is vy, this. So as the projectile is going up, as well as when the projectile is going down, there are two different solutions to the question कि the velocity vector v makes 30 degrees with the horizontal. ठीक है, तो हम दोनों के लिए सॉल्व करेंगे, कोई दिक्कत नहीं है. उसके बाद we will see the answers if it makes sense or not. So essentially at a later point in time, the velocity vector is this. This is vx, this is v, this is vy. And after some time interval t, v, y. This is 30 degrees. So the question is, what is this time period after which this configuration is achieved? That's the question. As simple as that. After how much time, Vivek, your answer is correct. After how much time has elapsed, this configuration is achieved? Because initially, it was 45 degrees. But at a later point in time, the angle changes and it becomes 30 degrees. So what do we do? क्या कर सकते हैं यहाँ पे? Anybody? What can we do?
So we can take the general expression for Vy, that is in Vx, in the Vuy minus Gt, and replace it, and you know the value of tan 30 degree, and that we can do it.
So we substitute everything here. That's what you're saying?
I have not done it in this way, but yeah, we can substitute in here also.
But यहाँ पे टाइम तो नहीं है ना, हमें तो टाइम कैलकुलेट करना है. आप कौन सा बोल रहे हो?
I have calculated that tan theta is equal to Vy by Vx. So the
हाँ.
tan 30 is equal to
So
Vy by.
समझ गया. So what you are doing is you are looking at the you are first trying to calculate Vy, है ना? First you are trying to calculate Vy, and one way of calculating Vy is from this geometrical diagram that tan 30 is equal to Vy upon Vx. Yes or no? Everybody?
Yes, sir. Exactly.
Yeah. Understood. So this is a vector X diagram. And in a vector diagram, you know from vector algebra, you might have studied vector algebra like in class 11th, right? That the vector algebras form a triangle. And the length of those vector arrows gives us this particular angle 30 degree, right? So tan 30 is equal to Vy upon Vx. I'm sure everybody knows this. Answer is Monzurul, it's not the correct answer. So from here what we can do is, from here we can obtain Vy. यहाँ से मैं Vy निकाल सकता हूँ. ठीक है? तो tan 30 क्या होता है? tan 30 is equal to 1 upon root 3. Vy क्या है? हमको नहीं मालूम. Vx क्या है? 10. So therefore Vy is equal to 10 upon root 3 meter per second. So we have obtained Vy then, just from a geometrical interpretation. Yes or no? बताइए. Correct है? Everybody? Correct है? Just from a geometrical interpretation, we have obtained Vy.
Yes, sir.
But यहाँ पे एक और चीज notice कीजिए that Vy is not necessarily always positive, because as the projectile is going up, Vy is positive, but as the projectile is going down, Vy is negative. So it's basically plus minus. Okay, Vy can be positive as well as negative depending upon whether the projectile is going up or down. Now the question is, we have obtained Vy, so now I want to obtain time. So उसके लिए मुझे कुछ करने की जरूरत नहीं है. Let us just apply this this equation. That's it. Equation number 2. Time और speed का relationship आ जाएगा. So if we use equation number 2, we will get Vy is equal to Uy minus Gt. तो एक solution हम use करते हैं 10 upon root 3 is equal to Uy is nothing but 10 minus G is equal to 10 T. तो ये क्या हो जाएगा? 10 T is equal to 10 minus 10 by root 3. So 1 minus 1 upon root 3. So therefore, time is equal to 1 minus 1 upon root 3 seconds. That's it. Option number A is the correct answer. Answer is option number A. It was not very complicated at all. All we had to do was connect the dots. I wrote down everything that was given to us. I wrote down what is the unknown. And based on the system, I tried to find out the unknown. First, I tried to find what is Vy based on the geometrical interpretation. And then I connected Vy with time using this equation of kinematics. And from there, we got the answer. ठीक है? मैंने यहाँ पे ये भी बोला है that the Vy can have two distinct values if Alternate possibility, if we take Vy to be negative, we will get minus 10 upon root 3 is equal to 10 minus 10t. So this is going to become 10t is equal to 10, 1 plus 1 upon root 3. Okay, so therefore t is equal to 1 plus 1 upon root 3 seconds. So essentially, the first configuration is achieved at t1 is equal to 1 minus 1 upon root 3 seconds. And the second configuration is achieved at t2 is equal to 1 plus 1 upon root 3 seconds. That's it. Clear here? The whole point is that you should be able to use whatever tools are at your disposal to solve the problem at hand. और problem में कुछ भी पूछा जा सकता है. It's a very number of questions are enormous. But is this question clear? बताइए. आगे बढ़ सकते हैं? Everyone?
Yes, sir.
Let me give you a little bit of a similar question, which not 100% similar, but more or less. A particle is projected with a speed of root 2 gh at 60 degrees with the horizontal. At what height its direction of velocity makes angle 30 degree with the horizontal? This is like exactly similar to the previous problem, but the only difference is पिछले क्वेश्चन में पूछा था after how much time. इस क्वेश्चन में पूछा है at what height the direction of velocity makes 30 degree with the horizontal. Try. You can use the same method as last time. The only difference is पिछले सवाल में पूछा था after how much time, इस सवाल में पूछा at what height the velocity vector makes 30 degree with the horizontal. Take 3 minutes. Bamdev, Rakesh, correct answer. Swarnava also correct answer. This question is exactly similar as the previous question. The only difference is that instead of asking the time, they are asking the height at which the velocity vector makes 30 degrees with the horizontal. Okay? Very much similar to the previous question, but instead of the time, they are asking us the height at which velocity vector makes 30 degrees with the horizontal. So let me write down all the given information. All right. यशवंत करेक्ट आंसर ओके सो ये प्रॉब्लम कैसे कर सकते हैं हम लोग वी कैन डू द सेम थिंग हियर फॉर द प्रोजेक्टाइल मोशन जैसा हमने पहले करा था द ओनली डिफरेंस इज दैट इन द प्रीवियस क्वेश्चन वी ट्राई टू कनेक्ट वी वाई विथ टाइम बट इस क्वेश्चन में वी नीड टू कनेक्ट वी वाई विथ एच ठीक है तो सबसे पहले लेट अस डू द सेम कैलकुलेशन हियर जो मैंने अभी थोड़ी देर पहले करा था दिस कैलकुलेशन ओके लेट अस डू द सेम कैलकुलेशन हियर है ना we did this calculation and when we did this calculation tan 30 is equal to vy upon vx so vx is equal to vy upon vx vx is equal to gh upon 2 so vy comes out to be gh upon 6 प्लस माइनस ठीक है ये vy आ गया बट नाउ टू फाइंड h विच इक्वेशन कैन वी यूज बताइए vy हमने फाइंड आउट कर लिया but to find h the height at which this configuration is achieved what can we do
V square equal to U square minus 2AS.
yes we can use the second kinematics equation that vy square is equal to uy square minus 2gh that is all so vy is equal to g capital H upon 6 uy is equal to 3g capital H upon 2 minus 2g small h. So therefore, 2g small h is equal to 3g capital H upon 2 minus g capital H upon 6. So this is equal to 6. So 3 into 3, 9 minus 1, 8 g capital H upon 6. ये हो गया 4, ये हो गया 3 and we will be left with 2 G small h is equal to 4 G capital H upon 3, or small h is equal to 2 capital H upon 3. That's it. That's the answer. 2 capital H upon 3, option number B. So you see the questions on projectile motion are very much similar to questions related to kinematics, that you just have to be familiar with, how to relate the various quantities like velocity, velocity components, distance, time, etc. etc. If you can do that, then these questions are not at all complicated. यहाँ पे हमें force equations के साथ deal करने की ज़रूरत नहीं होती है. We don't really have to solve differential equations. All we have to do is deal with the various kinematics equations. Okay, let's move forward. Let us do some more problems, क्योंकि ये एक ऐसा topic है जहाँ से questions मतलब questions can come in any manner. Let me give you one more question.
Give some hard question.
Hard question. Okay, let's see. Hard question. ओके, एक थोड़ा सा अलग टाइप का क्वेश्चन है, हार्ड ही कहूंगा मैं, ये जैम का क्वेश्चन है. ठीक है, सो लेट अस सी इफ यू कैन डू इट. सो दिस क्वेश्चन इज बेसिकली प्रोजेक्टाइल मोशन इन पोलर कोऑर्डिनेट्स. ठीक है, हमने प्रोजेक्टाइल मोशन को स्टडी किया है इन एक्स वाई कोऑर्डिनेट्स, बट दिस क्वेश्चन बेसिकली हैज टू डू विथ स्टडिंग द प्रोजेक्टाइल मोशन इन पोलर कोऑर्डिनेट्स, व्हिच इज आल्सो वेरी इंपॉर्टेंट. ओके, मैं डायग्राम को यहां से एक सेकेंड, just a moment, let me, this is not the actual diagram. The actual diagram is slightly different, just give me a moment. Okay, yeah, so a projectile is fired from origin O at an angle 45 degrees from the horizontal at the highest point P of its trajectory. The radial and the transverse components of its acceleration in terms of g are what? ये जैम का क्वेश्चन है. ठीक है, I forgot which year, but it was asked in IITJAM. So they are asking you a very simple question. If the particle is at the highest point, what is the radial and the transverse component of acceleration? So they're not asking you acceleration in x-axis or y-axis. They're asking you the acceleration in radial direction and transverse direction. So you're familiar with polar coordinates. You know how to draw the position vector. You know what is the radial direction. You know what is the transverse direction. Please find out the radial and the transverse acceleration component at the highest point. Options are also given to you. Swarnava, your answer is correct. Very good. Anyone else? So in this problem, you will have to combine two things: your understanding of projectile motion as well as your understanding of polar coordinates. Because यहाँ पे radial और transverse component पूछा गया है acceleration का. तो quickly try to remind yourself कि radial direction कौन सा है, transverse direction कौन सा है, और उन directions में acceleration को कैसे calculate कर सकते हैं. Vivek and Rakesh also correct answer. Anyone else? All right, we can start. So this is a very simple case of a projectile motion, and you are asked to find out the radial and the transverse components of acceleration, okay, at the highest point. So the highest point is P here, but what is interesting is that we need to start looking at this problem from polar coordinate perspective. So if we want to look at it from polar coordinate perspective, the first thing that I need to do is I need to look at the radial direction. Okay. So for that, I will draw a position vector. So let's suppose this is the position vector, right? And if this is the position vector, then the radial direction is just outward directed. That's it. This is the radial direction. Okay. Transverse direction क्या होगा? Transverse direction will be perpendicular to this radial direction. Nothing else. So this is the radial direction and this is the transverse direction. Okay. So we are interested in finding out the acceleration components in the radial and the transverse direction. So सबसे पहले तो we have drawn the diagram. We know what is the radial direction and what is the transverse direction. But I don't really know what are the force expressions in these directions. What do I know? I know that force is acting in the vertically downward direction. Yeah. This is the only force that is acting. Okay. So now what I can do is I can try to resolve this force along the various directions. So if I try to resolve the force along various directions, I can say that first of all, this is the angular displacement theta, which is not the same as 45 degree. 45 degree is the angle with the initial velocity vector. This is the theta, which is the radial, sorry, this is a transverse coordinate. And let's suppose I draw a direction here. So if this is theta, this is going to be 90 minus theta. This is going to be theta also. Okay. So now what I can do is I can say that if this is theta, then what is the force in this direction? The force in this direction is equal to mg cos theta. Okay. Now what is the force in this direction? This is mg sin theta. So हमने क्या करा? What we did was we simply took the force of gravity that was already present and resolved them along the radial and the transverse directions. This is the first step that we have to do. Otherwise, we won't be able to find out the acceleration components in radial and transverse directions, right? So we just look at the force equations. What is the radial force equation? Fr is equal to MAR. What is the force in the radial direction? It is minus mg sin theta is equal to MAR. Okay? M and M gets cancelled and AR is equal to minus g sin theta. All right. So this is the radial acceleration component for the particle at the highest point. Similarly, if we do F theta is equal to MA theta, F theta is equal to nothing but minus mg cos theta is equal to MA theta. M and M gets cancelled. So you have A theta is equal to minus g cos theta. That's it. So we have obtained the radial and the transverse acceleration components for the particle at the highest point. However, theta क्या है हमें नहीं मालूम. तो क्योंकि थीटा क्या है हमें नहीं मालूम, इसलिए आई एम अनेबल टू पिन पॉइंट कि ए बी सी डी में से कौन सा आंसर होगा. सो हमें थीटा निकालना है. थीटा निकालने के लिए क्या कर सकते हैं? एनीबडी? थीटा निकालने के लिए क्या कर सकते हैं बताइए? फ्रॉम द डायग्राम व्हाट कैन वी डू टू फाइंड
Tan
थीटा?
theta is equal to h.
Yes, correct. So we can do a same thing as what we did before. यहाँ पे भी हमने वेलोसिटी वेक्टर का कंपोनेंट को यूज करके फाइंड आउट किया था. यहाँ पे हम पोजीशन वेक्टर के कंपोनेंट्स को यूज करके फाइंड आउट कर सकते हैं. सो इफ यू लुक एट द पोजीशन वेक्टर कंपोनेंट्स, सो if we look at this triangle, so this is point O and this is point P, then this is theta. Then what is this? This is the height. What is this? That is half of the range. Okay. So we can say that tan theta is equal to height upon range upon 2. But हमें पता है कि height क्या है. Height is basically the total vertical height का formula क्या था? U square sin square theta upon 2g. ये थीटा नहीं होगा, 45 डिग्री होगा. U square sin square 45 degree upon 2g. So this is U square sin square 45 degree upon 2g times 2 times r. What is r? R is equal to u square sin 2 theta upon g. So u square sin 2 theta मतलब 90 degree upon g. So therefore u square gets cancelled, g gets cancelled, 2 gets cancelled, sin 90 is 1, sin 45 is 1 upon root 2 square. So therefore tan theta is equal to half. तो हमें tan theta तो मिल गया, लेकिन sin theta और cos theta नहीं मिला ना. Sin theta cos theta क्या होगा? Now what we can do is we can simply do some trigonometric calculations to find out what sin theta and cos theta are. So let's start with sin square theta plus cos square theta is equal to 1. This can be written as, if I divide the whole thing by cos theta, cos square theta, this becomes tan square theta plus 1 is equal to sec square theta, which becomes tan square theta is 1 upon 4 plus 1 is equal to sec square theta. So this is equal to sec square theta is equal to 4 plus 1, 5 upon 4, or cos theta is equal to 4 upon 5. Cos square theta is equal to 4 upon 5, or cos theta is equal to 2 upon root 5. Done. So if cos theta is equal to 2 upon root 5, sin theta is equal to 1 upon 1 minus cos square theta root over. So this becomes 1 minus 4 upon 5 root over, which is equal to 5 minus 4, 1 upon root 5. So finally, AR is equal to minus G sin theta, which is minus G upon root 5, and A theta is equal to minus G cos theta, which is minus 2G upon root 5. That's it. So our answer is option number D. Minus G upon root 5 minus 2G upon root 5. So this is a question that requires that not only you have an understanding of projectile motion, range, height, vagera vagera, as well as using this kind of a trigonometric sort of an expression to find out theta, but also an understanding of polar coordinates, so that at any random location you can draw a position vector, and then you can associate some sort of a radial direction and a transverse direction, and also a capacity to resolve forces. हमें पता है कि gravity है, तो gravitational force को हमें resolve करना है theta direction में as well as radial direction में. If you understand all these 2-3 things, you can connect the dots to come up with the answer to this particular problem. ठीक है, चलिए थोड़ा सा एक और सवाल करते हैं. Now this question is a question from TIFR. Let me give you the question, you can try. TIFR 2013. All right. So TIFR 2013. A stone is dropped from the top of a tower of height 40 meters. At the same time, a gun is aimed directly at the stone from the ground at a horizontal distance of 30 meters from the base of the tower and fired. If the bullet from the gun is to hit the stone before it reaches the ground, what is the minimum velocity that the bullet must have approximately? TIFR के जो questions होते हैं, they are relatively not complicated, but they are deeply conceptual. So first what you do is you draw a diagram. Try to understand what the question is asking. एक stone गिर रहा है, एक गन है जो 30 मीटर की डिस्टेंस से उस स्टोन को शूट करने की कोशिश कर रहा है. What is the minimum velocity that the bullet must have so that it hits the stone before it reaches the ground? Draw a proper diagram. Write down everything that is given in the question. Write down what is the unknown and how you can connect the dots to find what is unknown. Try. Last question of the day. Take 3 minutes. Try this question. Kashan, your answer is correct. Rakesh, not correct. Check again. Think about it. It's a very simple question actually. An object is falling from a particular height. A bullet is shooting something. Bullet is being shot at that particular object. What is the minimum velocity? Minimum velocity, maximum nahi. Minimum velocity that is required so that the bullet hits the stone. First, draw the diagram. Look at the various physical quantities. Look at what is unknown. और यहाँ पे आपको kinematics equations से ज़्यादा कुछ नहीं चाहिए. Just based on the kinematics equations, you can try to figure out the answer. Vivek, your answer is correct. Good. First, draw the diagram. Try to get an idea about. Rakesh, your answer is correct. Karthik, it is not correct. Check again. So just draw the diagram. What is happening? A stone is dropped from the top of a tower whose height is 40 meters. At the same time, a gun is aimed at the stone from the ground. Gun is aimed. Okay? This is the gun which is aimed at the stone initially. Stone was here. The gun is aiming at the stone. And the gun is at a horizontal distance of 30 meters. Okay? Now we are interested in the minimum speed. देखो क्या होगा? जैसे the gun is shot, the gun is not going to travel in a straight line. The gun will travel in a projectile motion. The stone will fall vertically downwards. But क्योंकि मुझे minimum velocity चाहिए, essentially I want the gun to shoot a bullet that just reaches the stone before it lands, like somewhere here. समझ रहे हो? This is the basically motion. Stone is being dropped vertically. Initially gun is pointing to the stone. Gun shoots a bullet. जैसे bullet बाहर निकलती है, stone is also falling down. And finally the bullet meets the stone somewhere in the middle. But हमें कोई random point नहीं चाहिए. We want the minimum velocity. Minimum velocity का मतलब है just before the stone lands, the bullet must hit the stone. That's it. ये वाला है आपका motion overall. Shall we start? Karthik, your answer is not correct. Shall we start?
Yes.
चलिए. All right, start कर देते हैं. So as you can see, the question is simple, and but it looks complicated. The TIFR questions are like that. It's a little bit deeply conceptual question. तो इसलिए मैं बार बार आपको explain कर रहा हूँ कि what is happening. A stone is dropped, and as the stone is falling, a bullet is shot. The bullet is also following a projectile motion. Minimum velocity for the bullet so that it reaches the stone before the stone lands on the ground. तो stone जब गिरेगा ना, कितना time लगेगा वो पहले calculate कर लेते हैं. Time taken by stone to reach the ground. ठीक है? It's vertical motion, कोई दिक्कत वाली बात नहीं. What is the distance? 40 meters is equal to ut. So 0, initially stone का speed 0 है, प्लस हाफ जी टी. जी को हम 10 मान लेते हैं, टी स्क्वायर. सो देयरफॉर टी स्क्वायर इज इक्वल टू 80/10, 8 हो गया, और टी इज इक्वल टू √8, मतलब 2√2 seconds. So this is the time taken by the stone to reach the ground. ठीक है? The bullet must hit the stone before this time. इस टाइम से पहले. Monzurul, your answer is correct. तो इस टाइम से पहले the bullet must hit the stone. ठीक है? तो if bullet has speed v, bullet का speed v है initially, तो मुझे एक बात बताइए, do I need to calculate the entire projectile motion, or is it okay if I just look at the horizontal speed of the bullet? अगर मैं सिर्फ हॉराइजेंटल स्पीड को ही देखूं तो भी तो काफी है ना, मुझे पूरा प्रोजेक्टाइल मोशन करने की जरूरत नहीं है. व्हाट इज द हॉराइजेंटल मोशन ऑफ द बुलेट? v cos थीटा. ठीक है? जिस टाइम में द स्टोन फॉल्स टू द ग्राउंड, v cos थीटा मस्ट बी सफिशिएंट इनफ टू रीच दिस डिस्टेंस. यस और नो? एक बार फिर से बोलता हूं. जिस टाइम में द स्टोन रीचेस द ग्राउंड, v cos theta must be sufficient enough to reach this particular point O, let's suppose. Yes? मतलब इधर से stone is approaching point O, और इधर से bullet is approaching point O. And just before the stone lands, I want the bullet to hit the stone. Are you understanding? तो इसका मतलब ये है that the horizontal speed of the bullet, which is v cos theta, ठीक है, must take the time t, okay, and that should be slightly greater than 30 meters. That's all. That's all. We are looking at the limit, right? We are looking at the limit. So in this much time, stone lands. So in this much time, v cos theta must complete 30 meters. This is the condition. समझ आ रहा है सबको? बताइए. Bamdev, correct answer. Monzurul also correct answer. Yes. ये condition सबको समझ आ रहा है? जिस टाइम पे stone falls down, उतने टाइम पे bullet reaches point O. That's all. That's the limiting condition. So then from here I will get the V. So if I solve this, V should be greater than equal to, because I'm talking about minimum velocity. So minimum is basically V is equal to minimum velocity. So 30 upon cos theta times t. So this is equal to 30 upon theta क्या है? अच्छा, थीटा भी फाइंड आउट करना है. cos थीटा क्या है?
3/5.
3/5.
सो ये हमारा होगा 40 स्क्वायर प्लस 30 स्क्वायर रूट ओवर, तो ये हो जाएगा 40 स्क्वायर इज 1600 प्लस 900, so this is equal to 2500, so this is equal to 50 meters. So cos theta is equal to 30 meters upon 50 meters, so 3 by 5. So this is 3 times 5 and time is 2 root 2. So 3 हो गया ये 10, 2 से हो गया ये 5. So 5 into 5 is equal to 25 upon root 2. So 25 upon root 2 is approximately equal to 17.7 meter per second. So the limiting condition for the bullet to hit the stone right before it lands on the ground, it must have a minimum velocity of 17.7 meter per second. If you look at the calculations, बहुत ज़्यादा calculation नहीं था. The calculations were not too much. I just calculated the time period for the stone to reach the ground. I just calculated the speed of the bullet for the bullet to reach this point in that time period. That's it. But this question, I don't think many students will be able to solve. Okay, because even though it's a question related to kinematics, thoda sa you need to have a deeper understanding of how things are happening. So projectile motion में जो है questions come in all kinds of exams. TIFR में भी आपको देखने को मिलेंगे, JAM में भी आपको देखने को मिलेंगे, and questions, they don't require you to solve force equations. They don't require extremely complicated expressions. They simply require equations of kinematics. ठीक है, कभी रेंज का एक्सप्रेशन चाहिए होगा, कभी टाइम ऑफ फ्लाइट का एक्सप्रेशन चाहिए होगा, कभी हाइट का एक्सप्रेशन चाहिए होगा, कभी वेलोसिटी या डिस्प्लेसमेंट का इक्वेशन चाहिए होगा जो मैंने डिराइव करा. व्हाटएवर इज नेसेसरी, बट एट द एंड ऑफ द डे इसी में से आपको कोई ना कोई इक्वेशन को यूज करके यू हैव टू सॉल्व अ पर्टिकुलर प्रॉब्लम. एंड प्रोजेक्टाइल मोशन में बहुत तरीके के क्वेश्चंस हैं. आई विल गिव यू सम मोर क्वेश्चंस एज होमवर्क. प्लीज गो थ्रू दैट. ठीक है, try to solve it yourself. At the end of the day, in mechanics, the more you practice, the more you feel comfortable with the topic. Otherwise, there are so many new types of questions that are going to challenge you. Every time you take a look at a new question, you will feel challenged. Okay, so the only way to get comfortable with mechanics is to practice more and more and more. There is no end to practice. Okay. What I am trying to do is I'm just trying to give you an exposure to the different kinds of problems. That's all. Concepts तो बहुत simple है. I'm just giving you an exposure कि अच्छा ये इस तरह का सवाल भी हो सकता है, उस तरह का क्वेश्चन भी हो सकता है, so that you have a general understanding कि अच्छा ये क्वेश्चन ऐसे किया था, वो क्वेश्चन वैसे किया था, अब मुझे एक अनसीन प्रॉब्लम मिला, यहाँ पे भी मैं वो पुराना अप्रोच यूज कर सकता हूँ. That's all. I'm just trying to make you feel comfortable with it. But यहीं पे खत्म नहीं होता है. You have to practice also. Please go through the homework problems that I'm going to share. In the next class also, I will discuss some more questions on kinematics. क्योंकि kinematics में बहुत तरह के questions हैं. ठीक है, equations are not complicated, but the nature of questions are very complicated. So questions related to projectile motion, questions related to polar coordinates, radial velocity, transverse velocity, questions related to bouncing objects, repeated bouncing objects, वगैरह वगैरह. I will practice again in the next class. ठीक है.